Has this ever happened to you that, let's say, you have created an AI application and it's not working fine? Suddenly, some person comes and says that, hey, can you show me your code? And that person looks at your system prompt, does some magic, and suddenly everything starts working. If I face this, then you have probably spoken to one of the prompt engineers, which used to be a six-figure job at a certain point of time. But as of 2026, it's a persona that you need to carry with you if you're trying to build your career as an AI engineer. So in this video, we're going to talk all about prompt engineering, what it is and how does it work. But before that, if you have not subscribed to TestMeU AI's YouTube channel, I request you to do so, because they have some amazing content created by amazing creators across the world just for you on testing AI and technology. Let's get started with this video. So as I was saying, this prompt engineer role used to be a six-figure salary at a certain point of time, and it used to be very guessing game when people are actually trying to make LLMs respond with exactly what they needed to. So there is a lot of trial and error that kind of came in, and that's why we term them as whisperers, right? Today, the reality is that we need to be an engineer. We need to have a new way of building consistent and predictable systems, right? And this is where we cannot afford to basically make sure that when I ask a question in one way, LLM responds in one way. When I ask it in a different way, the same question, it responds differently. I want a specific set of outputs the way I want LLM to respond, so that I can use it in my engineering solution, AI engineering solutions. And that is the reason where we see a shift where prompt engineering is coming as a persona inside the AI engineering itself. But before I go ahead, I think I want to clear one confusion here. There are two things. One is prompting and the other is prompt engineering. Now, prompting is about how normal users basically talk to AI systems, right? And many times you probably heard this, people using ChatGPT or Gemini saying that, hey, these are all giving me generic answers, right? I don't need this generic answer. I need specific answers. And why they're giving generic answers? Because the way we are asking is generic, right? When we make our question specific with more and more context, you will see that we are getting more and more specific results out of these systems. So context is very important. And prompting refers to how we basically train users when we create an AI system so that they talk to the system properly. Whereas the prompt engineering is a little white box thing, right? Where you have to write the system prompt of an application that you are actually creating. For example, let's say for a fashion company, you have created a chatbot whose responsibility is to talk to the customers and try to tell them a good combination of clothes that is suitable for a specific occasion. Now, you don't expect, when this solution is created, you don't expect your customers to come to that chatbot, which is created for this specific reason, and say that, hey, you are one of the finest fashion designers in the world, and your job is to do this, etc. You need to write a system prompt, couple it with lot of engineering around it to make that system. And AI engineering, in my opinion, is all about that, right? So we in this video are going to talk about prompt engineering. So I'm not going to talk about that, hey, this is how you should write your prompt, this is how you should first give it a persona, then you are going to give it some instruction, then you are going to give some context. You will find many frameworks for these things happening. We are going to talk about what exactly is prompt engineering, which is happening as a system prompt for the solutions that you are going to create. Now, we need to understand, before we go to prompt engineering, we need to know that engineering, which is nothing to do with prompt engineering, is kind of deterministic, right? So when I have an input which is 1 + 1 = 2, is always going to be 2, right? Output is always going to be 2. Whereas if I ask LLMs that what is 1 + 1, output might always be 2, but it might be accompanied with certain things which we don't want in our system that we are trying to build. For example, 1 plus 1, LLM might respond 2, just the way it is happening in engineering cases, deterministic cases. But it can also say 1 plus 1 equal to 2. Or it can say your answer is 2, right? If I don't specify in my system prompt how I want my output, this is how an LLM, which is a probabilistic in nature, can basically give you the same response in multiple different way, which for LLMs might be a feature, but for the entire software that you are trying to create might turn out to be a bug, right? So for example, in this picture, if you see input A, for in the same case, LLM kind of responds that maybe this or that or possibly this. You don't have any control over that because it is probabilistic in nature. And slight changes in input can give you unpredictable changes in output. And in one of my videos where I was talking about AI agents and their reasoning, I spoke about this. It's called token bias. So if you have not seen this video, I request you to go and watch it to understand what is this token bias in details. Now, let's take a use case, right? Let's say I have created a system whose responsibility is basically to show to the user, given a bug ID, what is the analysis around it, right? Now, the user input can be in any form, right? But for my application that I have created, I need a strict JSON which needs the key value pair, and the keys are basically summary, severity, and steps. So idea is that user provides all the bugs and the logs, some process happens, and the response comes in JSON. That JSON gets fed to the system that I have created to basically show in a nice dashboard to everybody what is the analysis by the LLM. Now, the problem that, as I was saying, that this one may come as a feature to the LLM that, hey, sure, here is your JSON that you have asked for, which is basically conversational filler. So sure, here is the JSON you asked for is a conversational filler, and I don't want that. I just need the output as a JSON, because if I don't get the JSON, when anything else which is getting appended with the JSON is going to break the system that I'm trying to build, right? The other thing that might be happening is that there might be a schema drift. Now, what is schema drift? In the previous, I need a summary, but LLM might choose to call summary as synopsis, right? To give me more more information about this bug. Or sometimes it comes as a plain text response, which is a format failure. I need a JSON, but it comes as a text. And the system that I have built, let's say I have built a React system to show a nice dashboard to the user, which actually requires me to have this JSON in this format. That is my schema. The entire application will break because JSON will not come as an output from the LLM. So LLMs are friendly, but they're sloppy. So there is no failure from the LLM perspective in all these three cases that we have discussed, but this makes my system that I've created using the LLM crash, right? And this is where we come to understand what is prompt engineering. And there are three things that I want to talk about when it comes to prompt engineering. One is you can think of this as a triangle. There is something called contract. So you need to define your contract beforehand, that how you want your output. In our previous use case that I had, our output has to be JSON, right? So if you need a string, you have to say it's a string. If you need an enum, you have to say an enum, or anything. You have to define your output beforehand. What is the contract that LLM has to bind itself? Well, it gives you the response and nothing else. The next in the triangle is control loop, right? So validating every response. And this is where the engineering also comes in. It's not just prompt, but it is also the engineering which is getting attached to it. Which means that whenever a response comes, look at this response, and if it is not the valid one, retry it, right? With stricter instructions. These type of things can also get appended when you try to write the system prompt, but sometimes you'll also add a little bit of engineering around it. for your custom solution that you're building with the LLMs. And the third is observability. So you need to understand a specific type of input, what type of output it is giving, right? So and for that you need to understand a specific observability, because even though I said that the whisperers don't exist anymore, but there is a bit of trial and error attached to it as well, even though you write a very, very good prompt. So you need to have this observability and see what is the small tweaks that you can do in your prompt. Remember the token bias that I was talking about, to make sure that that the response is exactly how you want for your AI application that you are trying to build.